Good morning. We are going to review a little bit of what we did last time, because I think that some of the notes weren't clear enough. So a polynomial is a smooth and continuous graph. So no corners, no gaps. Could this be the graph of a polynomial? Okay, good. If you're watching this later, just write down yes or no with a little sketch of the graph, and you can upload those answers later. What about this graph? Could this be the graph of a polynomial? Could this be the graph of a polynomial? That's right. Why not? Absolutely. It's this corner. Okay, what about, let's see. What about this graph? Could that be the graph of a polynomial?
No.
And good. Why not? That's right. Polynomial can't have gaps. So this graph is not continuous. This graph has a corner, so it's not smooth. This is the only graph of the three that could be a polynomial. So this is yes. All right. In standard form, a polynomial looks like lots of terms added or subtracted. The power term is the first term, or the term with the highest exponent of x. We call that the leading term or the power term. A sub n is the number in front, and n is the highest exponent, and we call also n the degree. A sub 0 is also called a naught. We read sub 0 as the word naught. A naught is the constant term, and the y-intercept is 0, a naught, if the polynomial is in standard form. So it's easy to find n in standard form. It's easy to find the y-intercept in standard form. But to find the zeros, we have to factor. In factored form, a sub n, the leading coefficient, is the number out front. To find n, we have to add up all the exponents on the factors. So we say that n is equal to p1 plus p2 plus ... plus p sub n m. That's going to be the degree of the polynomial, and we care whether or not that's even or odd. The zeros are from the factors. So we would say z1, z2, z3, to all the way up to zm are the zeros, and that P1 is the multiplicity of Z1, P2 is the multiplicity of Z2, P3 is the multiplicity of Z3, all the way up to Pm. So the exponents give you the multiplicities. Again, the power term gives you the end behavior, and we care whether or not n is even or odd, and we care whether or not a sub n is positive or negative. This is the graph that I want you to keep with you. If n is even and a sub n is positive, the graph will go up to the left and right.
Wait. I'm trying to figure out my computer real quick.
Okay, I can hear you, Octavio. I don't know if you wanted me to hear you. Oh, thanks, Octavio. I see. So Borja, maybe you can let Octavio back in when he gets his computer fixed.
Yeah, sure.
If n is even and a sub n is negative, the graph will go down to the left and down to the right. If n is odd and a sub n is positive, the graph will go down to the left and up to the right. And if n is odd and a sub n is negative, the graph will go up to the left and down to the right. That's the notation I want you to use, with this notation at the bottom. Down to the up, down to the left or right, up to the left or right. The multiplicity of a zero is just the exponent on that factor. So we would say if we have x minus z sub k raised to the p sub k, whatever these numbers are, then we would say z sub k is a zero of multiplicity p sub k. So in other words, 3 would be a zero of multiplicity 5. Since 5 is odd, the graph will cross at the 0, 3. A polynomial can have at most n minus 1 turning points, places where the function changes from going up to going down or vice versa. And if the polynomial is in factored form, it is in standard form.
Why are my speakers not working? What the hell?
I can hear you, Octavio, but you can't hear me?
Yeah, I can't hear no one.
Carlos, you can't hear?
I can hear you now.
Okay, I can hear you and you can hear me now. I understand, Bree. Is Bree on yet? Okay, please let me know whether or not you can hear. So everybody respond, yes, I can hear, or no, I can't.
So I can hear you just fine.
I can hear.
Okay, okay, good. So I'm not sure what's going on, Octavio. Okay, good. All right, let's go ahead and keep going. So we really need to know when we look at a polynomial, whether it's in standard form where everything is added or subtracted, or factored form where everything is multiplied. So here's a polynomial. What form is it in? Are things added and subtracted, or are things multiplied? I can't hear you. Are things added and subtracted, or are things multiplied? Yeah, they're added or subtracted, so it's standard form. That means that we know some things more easily than in factored form. We know that this first term, the term with x to the highest exponent, this is going to be the power term. What is n then? What will n be?
Even.
So in standard form, n is just the exponent of the power term. So in standard form, n is just the exponent on the power term. What is a sub n?
It's 1.
Good, because there's nothing written here. All right, that means that, what do we care about with n? We care whether
N
it
is-
is,
Even.
here's even, and what do we care about with a sub n?
Positive.
Positive. So I'm going to get my chart out. And here's n even, a sub n positive. The graph is going to go up to the left and up to the right. So that's the end behavior. I know that at the ends, the graph will go up to the left and up to the right. In standard form, in order to find the zeros, we have to factor. Well, this is a factoring thing we haven't quite seen before. We've got x to the fourth, we have nothing, we have x squared, we have nothing, and we have x to the 0. So we don't have an x cubed term, we don't have an x term. And this pattern is like a quadratic. Because there are 3 terms. To see this pattern better, let's let x squared be the variable u. So let's see, we've got, is x to the fourth the same as x squared squared? Okay, so I've got x squared squared minus 3x squared minus 4. And every x squared, I'm going to replace with u. So I have u squared minus 3u minus 4. And we're setting that equal to 0. Now, does that look like a quadratic equation? Good. Yeah, thumbs up or thumbs down, that would help. So either say out loud or chat, or just say, just thumbs up or thumbs down. So we need 2 numbers whose product is C, well, -4, and whose sum is B, B is -3. So tell me any 2 numbers you can think of whose product is -4.
2 and 2. Or
Okay.
1 and 4. 1 and 4.
So we've got -2 and -2. What is -2 plus -2?
-4.
Oh, one of these has to be positive, sorry. So what is -2 plus 2?
0.
Good. So that's not -3. So what is another option for getting to -4?
-4 and 1.
Good. And this time -4 plus +1 is,
It's -3.
and that's what we want. So we're going to write this quadratic as x minus 4, pardon me, u minus 4 times u plus 1 equals 0. But u was just a placeholder. U is actually x squared. So let's put that back in. X squared minus 4, x squared plus 1 equals 0. Can we keep factoring if we have x squared minus 4 as a factor? can we factor x squared minus 4 more?
Yes.
How does that factor?
Square root? No.
Yeah, the square root of x squared is
So x minus
X
2.
good. Times x,
plus 2.
yes, square root of 4 is 2. Square root of x squared is x, and we have a plus in one and a minus in the other. What about x squared plus 1? Could that be factored with real numbers?
Yeah.
Is it the difference of two squares? It's the sum of two squares, so
Yeah.
we can't factor it using what we know now. So now we've got all the way factored, and we're going to find the zeros. We're going to set each factor equal to 0 and solve for x. Oh, okay, so we're going to set x minus 2 equals 0, x plus 2 equals 0, and x squared plus 1 equals 0. And we're going to solve those for x. What do we get if we solve for x when we have x minus 2 equals 0?
Positive 2.
Good. And x plus 2 equals 0 gives us,
Negative 2.
excellent. Let's investigate x squared plus 1 equals 0. To try to solve for x, we're going to subtract 1 from each side. We get x squared is equal to negative 1. To get x, we need to take the square root of both sides. That means I need to put a plus or minus sign in front of one of the sides. And now let's look at those square roots. What is the square root of x squared?
X.
X.
Good. And we've got a plus or minus. What is the square root of negative 1? Is that a real number?
No.
That's right. So this is not a real number. And in fact, they're mathematicians, we've defined that the square root of negative 1 is equal to the imaginary letter I. So we could write this as x equals plus or minus I. But since this is not a number on our graph, we're not going to worry about it. We're just going to set that in our minds aside, because we'll see that later. But not, actually, if you're taking pre-cal, you'll see that later. Not later in algebra. All right, so we have two real zeros. And they are positive 2 and negative 2. So let's put those on our graph. We have positive 2 and negative 2. What is the exponent? Let's see, we had x plus 2, x minus 2, and x squared plus 1, all equal 0. What is the exponent on the x plus 2 factor?
1.
Good. So at negative 2, the graph will cross. What about the x minus 2 factor? Is it positive? Does it have an exponent of 1, or what does it say?
1.
So,
it'll
so
cross
1,
as well.
yeah, since the exponent equals 1 is odd, then it will also cross. And the last thing that we can write down is the y-intercept. In standard form, it's easy to find the y-intercept. It's just going to be 0, comma, the constant. Negative 4 is the constant. So the y-intercept is going to be 0, comma, negative 4. Oh, and we also have the total number of possible number of turning points. What is n minus 1 this time? N was,
3. Because it's 4 minus
yes,
1.
n was 4, and so it'll be, yes, very good. We'll remember that. And let's see, we've got our y-intercept is 0, -4. I remember that the graph is going up to the left and right. So here's kind of a picture of it. And let me show you what it looks like if you graph it with a graphing tool like Desmos. So I really encourage you to use desmos.com to graph these things. It's very easy to use, it's free, and it's always available. Oh, Brianna says she's waiting in the waiting room. Let's see. Just a second. Brianna, are you here? I don't see her. Let me check something real fast, guys. Okay. All right, I think she went to the wrong Zoom. Okay, so we've got, you can see that Desmos shows us what happens because of this imaginary factor. It actually does turn again, but we don't care at this point because it takes calculus. There she is. It takes calculus to know about these other turning points. So if you take calculus, you'll get more information about these graphs. For us, what we care about is up to the left, up to the right, crossing at 2 and -2, and the y-intercept. I want y'all to do this next problem. It's the same kind of pattern, x to the 4th with no x cubed, -2x squared with no x and a +1. So you need to find the end behavior, the zeros, and you'll find the zeros by factoring. The end behavior, how will you find that? Which term will you look at?
The power term and n.
That's right. Okay, good. The zeros you'll find by factoring. The multiplicities, where did they come in?
The exponents after you factor.
That's right. The exponents on each factor give us the multiplicities, and then the turning points, that's n minus 1, and the y-intercept. Because we're in standard form, it's just going to be the constant term, 0, the constant. So I'm going to go away. I'm going to listen though, and whatever you say, I'm going to write down. So please work together. Can y'all hear me? Can anybody hear me?
Yes.
Okay, so I want y'all to tell me what to write down. What is the power term here? If it's a standard form, which one is the power term?
4.
It'll be x to the fourth.
Mhm.
And that means that n equals
4 even.
good. And a sub n,
It will be 1, but positive.
good. That's right. So we can look at the chart. N even, a sub n positive, the graph will go up to the left and up to the right. How can we find the zeros? What do we have to do if the polynomial is, excuse me, standard form? What do we have to do to find the zeros?
You solve for x.
Yes, we're going to factor and solve for x. Good. So we've got 0 equals x to the fourth minus 2x squared plus 1. This looks like the same pattern we had before. 3 terms, but x to the fourth, x squared and 1, instead of x squared, x and 1, like a regular quadratic. So again, we're going to let u be x squared so that we can see the pattern more easily. So we have 0 equals u squared minus 2u plus 1. How would we factor that? What is C and what is B?
B is -2.
Good. And that's the sum. And what is B?
You mean C? 1,
No, what is C? Thank you. Yes.
1.
Good. And that's the product. So what are two numbers whose product is 1? Any two numbers.
1.
Good. So 1 times 1 is 1. What is 1 plus 1?
2.
Okay, is that what we want?
No.
Okay, so what are two other numbers whose product is 1?
Neg- mm,
-1 and -1.
Good. And this time, what is -1 plus -1?
-2.
-2.
Good. Is that what we want?
Yes.
Okay, good. So we're going to rewrite this as u minus 1, u minus 1. Hey, these match. Can I write that as u minus 1 squared?
Yes.
Good. And we need, can we keep factoring? Oh, we don't have x's. Remember, we just put u in there to make it easier to see the quadratic. So let's put x squared back for u. So you have 0 equals x squared minus 1 squared. Can we keep factoring?
Yes.
No, because it's a -1. It would create an imaginary number.
So is it a perfect square minus a perfect square? Because that's what we want. Perfect square minus perfect square, we can keep factoring. So what's the square root of x squared?
One.
Good. And what is the square root of 1?
1.
And we put a plus in one and a minus in the other. But how many x plus 1 factors do we have?
1.
So this whole thing, remember the whole thing was squared. So we've actually got 2 of each.
Oh,
So to find the zeros, now that we're factored, we're going to set each factor equal to 0 and solve for x. Okay, so we've got x plus 1 equals 0 and x minus 1 equals 0. What do I get if I solve x plus 1 equals 0 for x?
+1.
If I solve for x, I'm going to subtract 1, right? Is that right?
Sorry, I was looking at the one at the bottom. But yeah.
Okay, yes, so good. Okay, so the one at the bottom, we are going to get x equals +1. What is the exponent on the x plus 1 factor? What is the exponent on the x plus 1 factor?
Squared. So it's a even.
That's right. So we would say even multiplicity. And what does that say? Do I cross or touch at x equals -1? Let's look. With the multiplicities, even multiplicity touches, odd multiplicity crosses. Okay, so we're going to touch. The graph is going to touch the x-axis at x equals -1. Well, what is the multiplicity of x equals +1? In other words, what is the exponent on the x minus 1 factor?
2.
Good. And is that even or odd?
That's even.
So is the graph going to touch or cross at x equals 1?
Touch.
Good. Okay, so we've got x equals -1 and x equals 1. We know we're coming from the positive direction because we had up to the left and up to the right. So we're coming from above. Oh, we have one other thing we can write down. We can write down the y-intercept. We find the y-intercept how if we're in standard form?
You look at the constant, which would be +1.
That's right. So we'll
So it'd
get
be 0, 1.
good. And let's go ahead and write down the number of turning points. What was n?
4.
Good, so we've got 4 minus 1 is 3. That's the maximum number of turning points. Okay, oh, and what are we doing at 1 and -1? Touching or crossing?
Touching because it's even.
That's right. I have to turn in order to touch. I've got to turn at -1 and turn at +1. How many turning points do we actually have for this graph? How many turning points do we actually have? Well, we've got 1, 2, 3. So we have 3 turning points actually. And that's the maximum number. So we couldn't have any more. All right. This one is like what we did last time, but I think it's good to review. To find the end behavior with factored form. How can I tell that this is factored form? Factored form, everything is multiplied. And here I see everything is multiplied. To find n, we're going to add the exponents on each factor. Okay, so what is the exponent on the x plus 1 factor?
2.
Good. And on the x minus 3 factor?
1.
That's right. And on the x plus 4 factor?
Another 2.
And we get
5.
good. And is 5 even or odd?
Odd.
Excellent. What is a sub n when we're in factored form? Let's look at the deal again. In factored form, where is a sub n?
At the beginning?
Yes, it's the number out front. Let's see, the number out front this time is -1/4. And so what do we care about with a sub n?
If it's negative or positive.
Good.
This time it's negative.
This time it's negative. How fun. All right, so let's get our chart out. We have n is odd, a sub n is negative. So which picture am I going to use for the end behavior?
The last one.
Good. We have n odd, a sub n negative. We're going to go up to the left, down to the right. So my end behavior is going to be like this, up to the left, down to the right. In factored form, how do we find the zeros?
We make them equal 0.
That's right. We're going to set each factor equal to 0 and solve for x. So we've got x plus 1 equals 0, x minus 3 equals 0, and x plus 4 equals 0. What do I get if I solve x plus 1 equals 0 for x?
-1.
And x minus 3 equals 0?
A 3.
Excellent. And x plus 4 equals 0.
-4.
Now I need to find the multiplicities. That means I'm going to look for the x plus 1 factor and write down its exponent. So what is that exponent on the x plus 1 factor?
2.
Good. And I always circle the multiplicity, just makes it easier. All right. What is the exponent on the x minus 3 factor?
1.
Good. And what is the exponent on the x plus 4 factor?
2.
What do we care about with multiplicities?
It's even or odd.
That's right. So 2 is even. Even means touch or cross.
Touch.
That's right. All right. 1 is 1 even or odd.
That's odd.
So do we touch or cross at x equals 3?
We cross.
Good. And at x equals -1, do we touch or cross?
We touch again.
Yeah, because 2 is even. We're going to touch. So some things are lots easier in factored form. Some things take more work, like finding n. How many possible turning points will we have? Because n this time was 5.
We're gonna have 4.
That's right. 4 possible. And what is the y-intercept? What do I plug in to find the y-intercept?
0.
Good. So let's see, f of 0. That's -1/4. And I'm going to plug 0 in for the x. So x plus 1 squared, 0 minus 3 to the 1.
Oh,
Yeah, x plus 4 squared. So I've got -1/4. 1 squared is
1.
-3 to the first power.
3.
It stays negative.
Oh, -3.
And then 4 to the second power.
16.
Good. So I've got -3 times 16. That's -48. What is -48 divided by -4?
12.
Good.
-12.
Is it negative or positive if we've got two negatives?
Positive.
Positive.
Yeah,
Good.
positive. Positive.
So the y-intercept is 0, 12. The zeros are -1, 3, and -4. So -4, -1, and 3. And let's remember what we do. At x equals -1, we touch. At x equals -4, we also touch. And at x equals 3, we cross. And the end behavior tells me I'm coming from above on the left and I'm leaving down on the right. So that helps. Since I touch at -4, I'm going to bounce up. We also touch at -1. So I have to turn in order to do that. And then we cross the y-axis at 0, 12, cross the x-axis at 3, and there's kind of a picture. Let's see what it actually looks like if we use a graphing program. So touches at -4, touches at 1, crosses the y-axis at 0, 12, crosses the x-axis at 3, 0. But in order to see how these things behave, it takes calculus. So this is good enough for our class. Okay. I want y'all to work together, please, out loud so that I can write down what you're saying. We've got another polynomial in factored form. We want to find the end behavior, the zeros, the multiplicity of the zeros, the number of possible turning points, and the y-intercept. So I'm going to be here, and I'm going to write down what you say, but I'm not going to talk. So please turn your cameras on and unmute yourselves and talk.
All right, so I think we're going to start with the power term, which the power term is 1/3.
Mhm.
And then we're going to find n by adding up all the exponents. So we got 1, 2, and 2. So that would be 1 plus 2 plus 2, which would
5.
equal out to 5, which would give us an odd n. So from there, we know that the alpha, the a, it's positive, basically, the 1/3. And then we just know what our end behavior for that would be.
So going down left and going up right. Okay.
And then from there, we would find our zeros, which would
2.
basically be 2, yeah, 2, -3, and +4.
Mhm.
And then we would do the multiplicities for 2, which would be 1, so that would be odd. The multiplicity of -3 would be 2, which would be even. And the multiplicity of 4 is also 2, which would also be even. So that means at 2, 0, we would go through it. At -3, 0, it would touch it, and at 4, 0, it would touch it as well. And for our turning points, it would be n minus 1, so it would be 5 minus 1, which would be 4.
Mhm.
And for our y-intercept, we would just multiply everything. So it would be 1/3 times -2 times
3 squared
positive 3
So 3.
squared, yeah.
and negative 4 squared.
So we solve the exponents first, so it would be 9 and 16.
Mm-hmm. Negative, that would be negative 96. Wait, where are we?
So that's 288.
Negative
And that would
280.
be negative, negative. Ooh.
So our y-intercept would be 0, negative 96.
Mm-hmm.
What is the end behavior on the far left?
It would touch it.
The end behavior, this graph.
Oh, okay.
That
So
tells
it would
us,
be, it would going
Downwards.
from the bottom, yeah, from the bottom
that's,
up.
yeah. So that tells us where we come from. At negative 3, we touch, that's right. What do we
Then
do
we
at?
We
Yeah,
would go
okay.
through the y-intercept and then touch, oh no, go through 2, positive 2, and then touch 4.
And does that agree with our end behavior? Yes.
Yes.
Okay, great. Let's look at a picture of what this graph looks like if we use a graphing program. Let's find it. So you can see it's very similar. The graph comes from below, touches at negative 3, crosses 0, negative 96 at the y-intercept. Then we have a 0, 2, 4, 0, 2, 0, where it crosses at 2, 0, and touches at 4, 0, and it leaves positive. Again, in order to see where these turning points actually occur and how high they are, it takes calculus. So some of you are going to get to do that. Okay, we've got about 14 minutes. So let's do one example with a polynomial in standard form where we have 1, 2, 3, 4 terms. What kind of factoring have we done with 4 terms?
Group factoring.
That's right. We're going to factor by grouping. But before that, we can already talk about the end behavior. What is the power term? And why is it easier to find the power term in this example? This is standard form. So is the power term, do we have to add things to find the power term?
Yeah.
In
Nope.
standard form, it's just going to be the term that has the highest exponent on x.
Okay.
So it'll just be x cubed. So n is just that exponent. N is just going to be 3. What is a sub n?
Six.
It would be 1.
1.
Good. So what do I care about with n? What quality?
it's even or odd.
Good. And
No, positive or negative, right?
A sub n, positive or negative, n, even or odd.
Okay, is that were you asking a sub n or n? Sorry.
And I was asking about n.
Okay, okay, my
So-
apologies.
It's okay. Is 3 even or odd?
That's odd.
Good. And if it's, oh, so we're just going to record that. A sub n is 1. Is that positive or negative?
Positive.
So let's get the chart out. Here's n odd, a sub n positive. So we're going to go down to the left and up to the right. Again, to find the zeros, we're going to factor by grouping. So we've got x cubed minus 3x squared minus x plus 3. What's common between x cubed and 3x squared?
Sorry, can you
number?
say that again?
So what number is common between 1x cubed and negative 3x squared?
I'd say the x squared.
That's right. We have 3x's, we're pulling 2. How many are left?
1.
Good. And we've got negative 3x squared divided by x squared. What does that leave?
Doesn't it leave just a 3?
Good. Now, we've got a negative in front of the next term. Anytime we have a negative in the middle, we have to factor out a negative 1. Negative x divided by negative 1. Negative divided by a negative, is that positive or negative?
Negative.
Okay, negative divided by a negative is positive. But now let's do positive 3 divided by negative 1. What is a positive divided by a negative?
Negative?
Yes. Now we want to check, do the terms that we factored out, do they match?
Yes.
Great, so we're going to pull that factor out front and write down what's left. X squared minus 1 equals 0. Can we factor a little bit more? Can we factor x minus 3 anymore? What about x squared minus 1? Can we factor that anymore?
Yes.
Yeah, sure. That's the difference of 2 squares. So it'll be x minus 1 times x plus 1. And now we're completely factored. What are the exponents on each of these factors?
1.
Good. Anytime there's no exponent written, excuse me, the exponent is 1. So we can write down the zeros and the multiplicities. What is the 0 from x minus 3?
3.
Good. And its multiplicity?
1.
What is the 0 from the x minus 1 factor?
1.
And its multiplicity?
1.
Good. And the 0 from the x plus 1 factor?
Negative 1.
and its multiplicity.
Another one.
What do we care about with the multiplicities? What quality?
If they're even or odd.
Can't write, but yes, even or odd. And these are all,
Odd.
and what does that mean?
They cross.
So at every 0, we're going to cross. The end behavior is we're going to come from the below in the to the far left, and we're going to leave to the right. So let's see, let's mark down our zeros. We have 3, 1, and -1. And we started out in standard form. What is the y-intercept in standard form?
Should be the last number, 3.
That's right. So we would get 0, 3. We're coming from below. And what do we do at the zeros this time? Cross or touch?
We cross.
Good. Let's make sure this in behavior agrees. We came from below and we left above, and that's what we had. I think I have a pretty version of that. And this is just using Desmos.com. And it's very easy to use. You just write y equals the formula. So we got a pretty good picture this time. It's a little early, but I still want to, this is a good stopping point. So we did not do this example for y'all to do. But let's go ahead and look at it real quickly. At least the factoring part. If we have 0 equals x cubed plus 2x squared minus x minus 2, how many terms do we have?
Four.
4. And anytime we have 4 terms, we're going to factor by
Grouping.
good. What's common between x cubed and 2x squared?
X squared.
Good. And what's left?
And X.
And the 2x squared divided by x squared leaves
X.
2.
2.
We've got a negative in the middle. Negative x divided by -1.
X.
Good. -2 divided by -1.
1.
Almost. How about 2?
2.
Sorry.
Okay, and now it matches. The remaining factor matches, so we're going to pull it up front. We're left with x squared minus 1. Can we keep factoring?
Yes.
And tell me how.
X plus 1 and X minus 1.
Excellent. What are the zeros going to be for this graph?
-2, -1, and 1.
Good. And what are the multiplicities of these zeros?
All of them are 1.
And 1 means,
Odd in that it crosses.
that's right. When we're in standard form, how do we find the end behavior?
We look at the first
That's
term.
right. Good. The first term is
X cubed,
Good. So what is n
3,
and a sub n?
1.
What do we care about with n?
That it's even or odd,
Good. And a sub n.
positive.
So we've been seeing that pattern a lot. Still, let's look at the chart. A sub n odd, a sub n positive, we're going to go down to the left and up to the right. And we can almost finish this. So we've got zeros at -2, -1, and 1. What is the x, pardon me, the y-intercept? Because we're in standard form, it's easy to see.
-2.
0, -2, right?
Yes.
Okay, good. And let's see, I cross at every 0 and I'm coming from below. How many possible turning points do we have? In other words, what is n
Yeah.
-1? Yeah. How many actual turning points do we have? Do we have to turn between? Yes, we have 1, 2, and 2. So that's the most possible. Okay, let's definitely stop it there. I'm going to stop the recording instead of pausing it.